Thank you. Hello. Yeah, so I'll be talking about RAG varieties. But first, to quickly introduce myself, onto text is one of the ODBC members, founding member. We're developers of GraphDB, and overall, we are in the knowledge graph space, less so in the graph analytics space. So, what we believe knowledge graphs are most important for to serve enterprises is to help them connect the dots across data sources and essentially to turn the natural complexity of the global businesses into competitive advantage. We're best known for our database engine GraphDB, but we actually have a portfolio of offerings. What's most relevant for GraphDB as compared to any other colleagues around is that we developed it and designed it as a quite versatile graph database, being able to handle a variety of different workflows. With the obvious ones being semantic data management, where we come from, but also graph analytics. And that's the only engine which passed both the semantic publishing benchmark and the social network benchmark. Proving that we know how to handle both types of data loads, workloads. Going into graphs and knowledge graphs particularly, we don't need to convince anyone further that knowledge graphs are important, because over time everyone, including the journalists from Gartner, recognize that it has very high impact, actually the highest impact on this chart on various AI applications. Still, there are quite a few misconceptions, including when our team was preparing for Gartner DNA in one this year, quite a big conference, commercial one, and they were like, what graphs can do about LLMs? And this was all times the question. Well, there are quite a few misconceptions, because people say, well, graphs will validate LLMs and reduce hallucination. That this can be done, but it's not to use graph as a fact checker, but more like a teacher or something like that. And beyond that, AI has the capacity to help for many data management, knowledge management tasks. Getting to RAG and GraphRAG, I copied this picture from OpenAI's definition of what is RAG to help people comprehend that RAG is not only about document chunks, because that's the most popular variety. That's variety people see all the time. Give me your documents and then index them in a vector database, and that's RAG. In reality, RAG is much broader, about feeding LLM with much broader data, proprietary data context, whatever you want to call it. And then I had a hard time with our salespeople who got crazy about vector databases. And vector databases and doing vector indices is nothing new. The vector space model for information retrieval was published 50 years ago, and over the last 30 years, all information retrieval machines have vector indices in them. So, for instance, Elastic is a vector database for its core offering for about 20 years now. And finally, again, because RAG became so popular, people get to think that generative AI is all about RAG. Luckily it's not. So our vision is that AI can help graphs and generally data management in many times, probably the many ways, or probably the most important one is that now you can use Gen AI to talk to your data without having to invoke a DBA to make a query or report. That's much more instant now, and this essentially makes graphs much easier to use. All sorts of databases, but particularly graphs. Now, getting to the core of the presentation, the graph RAG varieties. There are many different ways in which graphs and knowledge graphs can be used to support a RAG setup. So our classification, which is now quite well adopted, is that one option would be to use a graph as a metadata store. So essentially, you have a knowledge graph that stores documents and metadata about these documents, and then you use this metadata to enrich the chunks, or in other ways to help you pre-select documents, and this way, provide more relevant and better quality data to the LM. The second option would be to use graph as a vocabulary, as a domain expert. And in this case, you not only provide the metadata about the documents eventually, but you can also provide the definitions of entities, for instance, so that to reach the chunks, and this way get again better results. And the third option, which is most complex and challenging to implement, is to use graph as a database. And in this case, you essentially translate either the entire question or part of this question to query to the database, get it answered by a graph database, and then you pass the results over to an LLM for summarization. And there are plenty of queries that can only be answered this way, because in the first two varieties, there is massive problem with the locality or globality of the information. Whenever you do chunky RAG, let's put it this way, you are limited to the number of chunks of content, enriched or not, that you can pass to the LLM so that it can answer the question. So in each and every case, when you have data spread across more than 10 chunks, more than 20 chunks, you need to use the graph as a database and make a graph query instead of counting that I'll find the best 10 chunks and I'll get the job done. So that's the third variety, is most powerful, but also natural language question to be translated to a valid query to a database is quite hard. Now, let's talk briefly about the types of graphs that are needed to serve these different patterns. Overall, whenever we're speaking of graphs, knowledge graphs, enterprise knowledge graphs, there is always, knowledge graphs are about having a conceptual model that describes your domain, the domain of your application. So it can include ontologies, data schemas, taxonomies, or other domain knowledge, as well as all sorts of entities and reference data. So that's always in the core of an enterprise knowledge graph, having this conceptual model and having it defined with all the relevant semantics, which is actually something that you can only do with RDF graphs. And then recently there are extended patterns of using graphs and knowledge graphs. One of them, we call it semantic content hub. So that's the story of essentially using a graph to get a better view, a sort of insight engine to help you better search, recommend documents. And then it's, of course, about such a system should index the documents, create and put some metadata in the knowledge graph. to facilitate this process. The other pattern is semantic data fabric. When you use such a graph, such a conceptual model, semantic conceptual model to access data that is spread across multiple database systems and enterprise. And then it's again about, to enable this, you need to put a lot of metadata about these databases to facilitate either ETL or virtualization, whatever means are used. So there are plenty of tools needed to implement these patterns and to create this metadata. Integration is necessary with CMS systems on the left or with data catalogs on the right. But if you get a knowledge graph which goes both ends, that's what people nowadays call semantic layer. So this is the combination of the knowledge content hub and data fabric, and all this amplified by or multiplied by, as in the formula, the conceptual model, and again using Gen AI in combination with this in a graph arc pattern. So to extend the table that I showed you before, let's see on the right what types of knowledge graphs, what architectural patterns are needed to serve these different types of graph arc implementations. So if you do use graph as a metadata store for documents, then you need a content hub pattern. If you want to use graph as an expert, then the domain knowledge and the conceptual model in the middle is actually most important. And to use graph as a database, you most often go to the data fabric pattern, so that you can get more information across different database systems. In the overall, our view of how knowledge graphs are combined with AI is that you don't have a single magic solution or single reference architecture that works. Solution architect should always decide what AI components to use based on what is the high-level task, and whether it will be one set of tools that you need for Q&A, for another for data integration, graph completion. There could also be very different non-functional requirements about privacy, about should it be a multilingual or English is okay, whether we are speaking a specific domain. This all matters. So at the end of the day, building any Gen AI solution and any graph rack solution actually requires a tool set of different AI components. Part of these components, what is really necessary for a good graph arc implementation, actually everything that goes into the graph arc type 2 and type 3 requires the so-called entity linking. That's the task that LLMs are very bad at. So whenever you have a text, that's the task of associating named entity references to very concrete entities, entity identifiers in the graph. And that's very important for instance, natural language query, because you typically transform the user question into graph query, whether Spark or Cypher, doesn't matter. But then you have to put as parameters in this query specific identifiers. And you can only do this if you can recognize the entities that people are asking for. And it boils down to essentially disambiguation. Whenever you have, for instance, Paris in the text, to figure out whether this is Paris in France or Paris in Texas or Paris Hilton. This is a tough task. And many people just solve it by saying, well, I'll use a vector database and you give me some candidates and I'm done. Well, that's the poor man's way of doing this. To get the best performance, decent performance for entity linking, for disambiguating, recognizing the best entities, you need a more specialized AI models, and this is not LLMs. Quite often you end up with a specialized transformer architecture. So, for instance, if you want to be able to recognize in text Wikidata references, there is a benchmark for this called AIDA, essentially, yeah, pre-annotated news articles, big volume. And there are many systems which benchmark them against it. So we do offer such component which is on par with the best systems at accuracy in the range of 76%. If we have to go at the bottom of this table, we would also see that in the medical domain, it will be a different AI component that you need for this purpose. We benchmark what we have against SNOMED challenge benchmark dataset. You wouldn't probably expect it, but this is very, very popular in the life sciences space. You have as many as 500 submissions for this challenge this year, and our submission got ranked number 7. So this is the set of tools, part of these tools that you need to enable integration of Gen AI with knowledge graphs to do the linking part and to know which pieces of the knowledge graph are relevant to the task. We have various features integrated, Gen AI related features in our graph database engine or metadata studio that's more about text analysis, or SEAL being the common English anti-linking model that I just spoke about. So wrapping up, as many colleagues, obviously, we did our best over the last couple of years to provide the tooling for to help people combine graphs and AI. We believe the most important points are that graphs should improve Gen AI performance by data quality most of the time and domain knowledge. If you can't do this, then you can easily get in, garbage out. So and data quality and domain knowledge is all about providing unified view towards diverse data with good contract, good specification about the meaning of these data. Then graph databases, and that's true for all the colleagues, provide a lot of integration facilities and support so that IT teams can more easily build these graph RAG patterns. What differentiates us from some of the colleagues is that we invested heavily through the years. That's why OnToText in text analysis tooling and AI models to complement their LLMs. That's all the way from having the environment to benchmark AI to benchmark text analysis components, to these anti-linking models, and so on and so forth. We happen to get quite a good visibility in this space. If you Google GraphRAG, would come number 1, number 2, depending where you query from. People can join this Graph AI and Graph and AI in Action group, where we publish relevant results, including a lot of GraphRAG postings. So thank you, and I hope we have a minute for some questions.